So let's move the session right along. So a quick introduction for myself and for my business at Schneider Electric. So I've been in the business for 35 years in the operational technology scope or sphere, 20 years with Schneider Electric. In the UK we have something like 49 sites, 4,000 employees in the UK and Ireland, and more importantly for this talk, since 2019 we started our net zero campaign to get down to by 2025, which I think is something like 5 years ahead of, or at least 10 years ahead of the international recognised targets. This is a real sustainability challenge, and it's driven in many ways by some of the foundation work that we started something like 16 years ago. In 2006, we set up our performance services group, which covered cybersecurity then and wireless solutions, really to try and address some of the issues we still currently face today, which is, how can you optimize manufacturing sites, buildings, many of the things that are at the forefront of the sustainability challenge as we speak today. So it's been a long time in gestation, but I think with the advent of the industrial Internet of Things, IoT, I think that's one of the final missing pieces in the puzzle, which is really going to drive and accelerate the step forward in sustainability that we really require and desire. So let's start with discussing, essentially what sustainability is. It's more than technology. Quite often we make the mistake of thinking about IoT as just being a technology discussion. It's much more than that, particularly when you get into the industrial sphere. It's really about a collection of people, and how they interact, processes, how they go about their day-to-day business. Technology, absolutely, it's at the core and fundamental to make it all work and in a coherent way. But almost more important than all those three is the idea of preparedness. It's thinking about your objectives, how you're going to achieve them, thinking and planning ahead so that you can use this thinking time really to get to a place where you can sustain the user in your operations, the organization that you're working within, the assets that you're deploying to manufacture, make things, or live in a happy environment, the cyber environment, absolutely. When we think of all those connected products, this is greatly increasing the footprint that we have for potential attack, and this then has a wider hit on the wider public. So if we put the network and the infrastructure together in an insecure way, then this can have effects which go much beyond the local operations. So why IoT is important is that when we started this sort of lifestyle change way back in 2006, 2005, we were working with one of the major oil players, and they discovered that in their plants that something like 70% of the assets in the field were what we call disconnected or islanded. So many of the day-to-day operations required someone to go out in the field with a pen and paper or pencil and paper, or even then just moving to a handheld device to take recordings of temperatures, pressures and flows, and then bring that back manually to their desk, feed in the information to an Excel spreadsheet. And you can think of the latency involved in recording this information, and then the gaps between the individual players in the process. Getting to an optimized solution which is sustainable was pretty much impossible. So we started some interesting projects then to fundamentally redesign and optimize the way the business processes worked by making those disconnected products connected in a way through human intervention, and this gave some quite startling results. So when we thought about it, if you gave the field operators who had their day job, which was to make sure that the manufacturing process was aligned and ready to go, if they were in their day-to-day work taking additional information, then there's a lot of useful measurement points, temperatures, as I say, temperatures, pressures and flows that could be actually collected and brought back to the plant. If that was then integrated, that could then be used for increasing operational efficiency. So the end point of that was that really an air gap or an isolated system was really not an option if you were thinking about a sustainability drive. And this proved very successful. So when we worked with our client at Arkema in Rotterdam, it's actually the project started 10 years ago. We discovered that through the preparedness, identifying the business case, thinking through the processes, identifying the people issues, thinking of how we could make this securely. So we deployed a secure wireless network with encryption at the access points. Thinking of the new ways of working, we actually had a complete shift change in the way that the plant was operating, to such an effect that they had something like a 75% shift occupation, which increased dramatically, which resulted in a 25% increase in production. So the improvement was marked, and we're happy to say that 10 years later this is still going in a sustainable way. So you can think of the improvement in operational efficiency, the improvement in baseline energy costs, quite dramatic with a 25% increase. This was not achievable with an air gap. So really the idea of thinking of having disconnected islands of operation in a connected way is really not going to work. You really need to have a fully integrated system, and to achieve that, we believe at Schneider Electric that you need to think seriously about the industrial Internet of Things and how this can then be integrated fully into your thoughts and plans for the future. Now, when you do that, you really have to think seriously about cybersecurity. I heard recently that if you think about the Internet, 40% of the traffic or more is filled with botnets. These automated ways of breaking into your system. That's not a good thing to have. So when we start talking to our clients about the nearly zero challenge from the European Union, say for 2031, we're thinking about this idea of sustainability and how it drives connectivity. Now, there needs to be a great awareness from our customer base that this then has a security challenge. So we were working with one of our clients in the UK, and these were some of the statements that I'm showing today which were raised during the request for proposal. So the first one was the BMS plant, the building management system, which is directly involved in energy, should be operated remotely with site-wide web access. This is common nowadays with reduction in workforce and specialists quite often having to dial in to review conditions. Related to this, there's quite often a commingling between the IT network and the OT network to reduce costs. And the third element, which I just picked out of the RFP, was the web browser access should be robust, and the possibility of remote hacking into the system shall be completely eliminated. So, from a realism standpoint, that is just a non-starter and an impossibility. You can never make a system wholly secure. All you can do is mitigate the risks and vulnerabilities that you've identified against the known or even unknown threats. So really, cybersecurity is all about risk reduction. It's a risk discussion, really. So there's a lot of discussion in the market about raising awareness and capability. So that's why the people piece comes in. It's really about increasing the knowledge and awareness of our customer base about the risks associated with this increased connectivity, which is an absolute driver for sustainability. So to assist us in that, Schneider Electric have backed the IEC 62443 standards. This is very much a defence in depth approach in risk reduction. We've segmented the key areas of interest into 3 primary zones. So the one is the connected products, the products that we ship and many others ship. to the world. Edge control, so that's the controllers and the operation systems that you have in the OT space, and then that then feeds back up through the internet and up to the cloud for apps, analytics, and advanced services. So this is very much this layered defense approach, as I've said before. Now, this layering of defense is associated with three separate things in three stages. The first one is the product itself and how that is designed, so it should be secure by design. The second one is through the system integrator or the consultants who are working with you to actually deliver a secure solution. And then finally, it's through the full asset life cycle and thinking about how that asset is owned and operated through its full design, which in the operational space can quite often be 20 or 30 years, unlike the IT space where you're quite often replacing machines every 3 to 5 years. So there's a bit of a paradigm shift there in the requirements. So we're talking about a defense in depth, 3 layers, with thinking about from an IEC 62443 perspective, we're thinking about products and solutions secured by design, system integrators delivering a solution which is secure by design, and then thinking about the capability of the asset owners to maintain that level of security through its full asset life cycle. So that's all fine and good, but when we think about IoT devices, many of which are delivered with security definitely not in mind, and then thinking that we're having to traverse across the internet, which is highly populated by botnets and other nefarious things, the IoT can then bypass your defense in depth. And thinking that that small device that's in your kettle or whatever could have the processing power of a 750-pound DEC VAX, I'm just showing my age, then serious issues can arise. So much so that if we think of that as an attack vector, a way into your system and we often call this a backdoor, something like 20% of companies that suffered attacks were delivered through an IoT device in the last 3 years, and that's reported by Gartner. So that's bad enough. But if we think of the difference between a cyber attack which hits the IoT space and one which hits the operational technology space, then we have to think very seriously about that, because within the IoT space, yeah, you could lose some time, but generally you can live with that 2 hours, 4 hours, even 1 week outage. It's an inconvenience. When you get down to the operational space, then we're thinking about potentially causing harm to assets, and that assets could be people, most importantly. That could be assets which are, many thousands or even millions of pounds or euros in value, or even that can spill out into the greater environment within the local populace. If you think of WannaCry, for example, which came very close to destabilizing our hospital system in a serious way. So we really have to take the security of IoT devices, very, very seriously because of this industrial connectivity. So the other aspect of the IT-OT difference is quite often that's talked about the integrity, confidentiality, availability triangle. But really I think it's more about the functional integrity when we get down to the operations management and automation space, because essentially when you drive an action, there is going to be a response. And when we think about it in a time frame, up at the IT environment, that could be a business management decision. So you can have a strategy review. We're going to improve our sustainability targets. We're going to get down to net zero by 2025. So we're talking about months or years. When that is rolled down to the production management level, then we have to think of different ways of working, how we're going to operate the assets. Example, that can take for a number of days if we're thinking about monthly targets, for example. Then we get into the idea about what you're going to make that day. So that's an operational target based on, how many tins of beans you want to get out the door, or litres of fuel oil, whatever that product may be. Then when you're into the closed loop automation, then we're thinking about seconds for a decision. So if an attack is made down at the OT level, the closer you get to the endpoint, which is in the process environment, the action time can be very quick. Now, it may well take a period of time to get there, but the adversary will go through those steps. And once they're at the point of impact, that impact can be very sudden and dramatic. So we have to take very seriously the security implications of this IoT solution as a whole. So IoT can bypass your defense in depth, but you can make it part of your defense in depth. So if you think of the IEC 62443 standards, we have to think about role-based access control. We have to think of patch management and how the devices are patched. We need to think of encryption of data in transit. So we're moving away from this 98% of data in transit is unencrypted. We need to think of encryption of data at rest if it's going up to the cloud. We have to think of physical security, who has access to those devices to potentially backdoor or bypass. So we have to think of anti-tamper. And then we have to think of legacy support. So once that IoT device, which is quite often commodity, is delivered to site, how long can you actually support it? So these are the questions you should be asking yourself when you're thinking about deploying IoT technology, because that can become the attack vector which gets to your process control system in a short-circuited way. So the time to action to moving from a good place to a bad place can be very dramatic. So the Schneider Electric view is that you need to think of this very, very carefully. Think about the IoT devices you're putting in place and think of their conformance to the IEC 62443 standards, and then how that is then incorporated within the overall architecture for this business improvement process. So if you were thinking of energy optimization, for example, you may well be thinking of using a device which was originally targeted towards equipment health. That hardware-based system is then feeding up to the cloud, which now becomes an optimizer. So you may well be feeding additional signals from the process control system. These also feed information into the optimizer, and the optimizer can think of where optimally you should be running the asset. That then feeds down a new set point to the process controller directly. Now, if you think about that, that's giving a direct drive to action. So you're also then having to think about how you're managing cloud security, but that's a discussion for another time. So hardware-based security is a way forward, we feel, in absolutely thinking about the role-based access control, the patch management, the encryption of data in transit, thinking about that data at rest issue. How are you actually going to protect those devices in the field with physical security and anti-tamper, and then the legacy support? Are you delivering technologies to the field which are going to be able to sit there for 10, 15, even 20 years? So these solutions are available through Schneider Electric, and I'll move on to the next stage about the case study. So this was a project we ran a number of years ago with a client in manufacturing. They had high pressure compressors, and once we'd made that connection between the field device through into optimization, really dramatic effects. So we're able to proactively ensure high value assets achieve their design life through the equipment health management. But by actually looking at the data coming from the process, it was identified that actually there was a sweet spot for those compressors. So you didn't have to drive them 100%. We could actually back them off down to, say, an 80% level and still achieve the production targets required. So it helped define that operational sweet spot. Once that sweet spot was effectively hit, then it opened up the idea of actually there's a massive energy reduction here. So this then alerts the operators on breaches of those limits. Now that limit, if we think about closed loop, could be driven by the optimizer so that it can act in real time. And it also gives the operator the capability to click on the tag to see what's actually happening in a trend view. But by and by, the bottom line was that it released something like $7,500 per month in energy savings. A fantastic win, both in energy and sustainability, but sustainability in two ways. One, energy targets were being met, which is often the narrow point of view, but also the asset was achieving its full design life. So to sort of wrap up, the key takeaways for a sustainable IoT infrastructure is moving towards optimization, finding that sweet spot. To achieve that, we think you should shorten your deployment times with secure reference designs. That preparedness piece, create efficiencies and reduce complexity in hybrid IoT networks with standards. Those standards are driven by the IEC 62443. And then increase sustainability with energy effective solutions. So always think of that sweet spot. So that's my time up. Thank you very much for your attention. I hope you've found it illuminating. I'm Victor Lough from Schneider Electric Cybersecurity Services. We're here to help on your sustainability journey, and feel free to contact me for further information. And I think we're on to a Q&A.